March 18th of 2025 brings us Java 24. Let's find out what's included.
Welcome to the Foojay Podcast, all your news about OpenJDK.
Every 6 months I serve you a podcast about the new Java version. I'm happy to have my regular guest Simon Ritter, Deputy CTO of Azul, also known as Speak Java on all social media. He is part of the OpenJDK Vulnerability Group, GCP Executive Committee, and expert group for the Java SE specification request, so he can share with us a lot of backside info. Today we are joined by Hanno Embregts, a Java developer by day and musician by night. He publishes a post on Foojay with all the details of every new Java release. And also for Java 24 he prepared a long description with all the new features that are included in this new Java version. Thanks Hanno and Simon for joining. We have a new Java version to celebrate, and it has 24 JEPs, Java enhancement proposals, so 24 JEPs in release 24. Simon, were you in the meeting where they decided to have 24 JEPs?
No, but I mean, this is a good point about the way that JEPs work, and the fact that we have the 6-month release cadence now. It just randomly, sometimes you will get like maybe 6 or 7 JEPs, sometimes you get 24 JEPs. It all depends on when those JEPs actually come to a point where they're ready for inclusion. And I think this demonstrates the power of how the whole JEP process and the 6-month release cadence works.
But I guess they pushed a few extra in, or they left one out to stick to 24. Or not?
I'm not sure about that. The reason I say that is because obviously 25 is going to be the next long-term support release. Now, I know that if you ask the OpenJDK people, they'll say, oh no, we don't consider long-term support releases in terms of when we put features in. But I think that there probably is a little bit of, shall we get things in for JDK 25, because it is going to be a long-term support release. But 24 being not a long-term support release is just, a feature release, as they call it.
So Hanno, you prepared a long blog post for Foojay with everything which is included. I was trying to find myself some structure in these 24 JEPs, but actually you already did that, and you grouped them a bit by topic. I think that's a good approach of how we can go through the list of these JEPs, and maybe I don't think we need to discuss them all 24 in detail, but there are 5 JEPs which are related to Hotspot and the garbage collector. Can you summarize them a bit? Maybe, Hanno, you can start with what's most important for you in this topic.
When I researched the different JEPs and when I was trying to get a nice reading article out of it, I quickly discovered that, a lot of changes are under the hood this time, right? So a lot of features are related to performance improvements or decreasing the size of a build JDK that you can create using JLink, for example, removals, deprecations. So like all kinds of work that is being done to further stabilize the platform and make it future-proof, I guess. And the changes in Hotspot really also make me think of that direction. So, for example, there are a few garbage collection expansions that have been done, for example, in the Shenandoah garbage collector that now also supports a generational mode, which we probably already know from G1, and the Z garbage collector as well, because that one also got generational mode in one of the more recent versions of Java. There's a JEP about late barrier expansion, which is kind of technical. I had to get deep into the garbage collection internals to really understand that one. And then I tried to, write about it in the article that you mentioned. But late barrier expansion is effectively an optimization of the C2 compiler, one of the just-in-time compilers that is used by the Hotspot JVM. And the fact that these barriers are placed later in the process means that it is more optimal and can potentially reduce the overhead of the just-in-time compilation process. And another feature that I really liked, because it's one of the first that comes out of Project Leiden, is ahead-of-time class loading and linking. I'm excited about that one because I've been following Project Leiden for some time now, and I think this is one of the first features that is published from that one. Means that you effectively you can start up a JVM and warm it up, so to say, and save the state of the warmed up JVM to disk, and then when you start the JVM up again, you can refer to that saved file, and the entire warmed up JVM will be loaded much faster than before.
I see you agree, Simon, with that one. It's an important one.
Yes, yeah. I mean, as Hanno says, there's several things under the covers that we're seeing with JDK 24. The Project Leiden is an interesting one because the first part of that is about ahead of time class linking and verification. So that's the sort of starting point, is that we can record the data associated with classes once they've been loaded and initialized, meaning that when we start up the application again, we don't have to go through the same process, and that will save time. But that's the first step in terms of Project Leiden. Next, we'll be looking at using the saved JIT compilation data so that we can avoid the overhead of having to figure out which methods are used frequently, then compiling them with C1, recompiling them with C2, and doing that. So funnily enough, this is very interesting because it's exactly the same as what we do on our platform Prime product in terms of ready now, because we've already done all of this. So we did initialize all the classes and linking all the classes, and we've done caching of the compiled code and things like that. So it's nice to see OpenJDK actually catching up with us on this particular one. So I mean, there was obviously there's a couple of other ones that are under the covers in terms of like improvement of the garbage collection. One I saw as well was shrinking the object header from down to 64 bits. Typically it's 96 to 128 bits. And you think to yourself, okay, so a few bits here, a few bits there, does it really make that much difference? But when you look at the reality of objects that you create in the heap, most of them are very small. So the impact of shrinking the object header like that can have as they claim in the JEP, it's sort of 10 to 20% reduction in the amount of space that's required for the heap. And that will be significant especially when you're running in small containers where you've got constrained resources. That could be something that really helps that type of application.
Another one related to the hotspot is Synchronize virtual threads without pinning, JEP 491. That was a problem related to virtual threads, which were introduced in 21, right? Was there something wrong with virtual threads?
Not wrong with them. It was a limitation that was applied to virtual threads. So if you look at the way that virtual threads work, it's the idea of being able to share what's called a platform thread or a carrier thread amongst a number of threads at the Java level. So you're effectively mapping multiple Java threads into a single operating system thread. And that works very well in certain types of application where you've got thread per request, and most of the time the thread is blocking on things like I/O. So it's spending most of its time asleep. But the limitation that they had was if you blocked within a synchronized method or a synchronized block, then you still couldn't switch to a different Java thread, so a virtual thread at that point. So in those types of situations, it was a limitation. What they've done now is to rework the way that the monitor is used in basically the synchronized keyword, so that it's up to the JVM and the Java thread to be able to control that use of the monitor, and that way the monitor can be released and reacquired, so that you can switch even when you're in a synchronized block.
The first time I encountered the fact that the virtual thread got pinned to these synchronized blocks, I was kind of confused, and then I researched it a bit, and then it kind of made sense, right? Before Java 24, a monitor could only be held by a platform thread. And that also means that if virtual thread number 1 enters a synchronized block and then is blocked, it can get swapped out by virtual thread number 2. Now imagine that both virtual threads are actually running on the same platform thread. That means that the second virtual thread can actually enter the synchronized block in the middle of the block. So that's a major security risk, of course. Not to mention the concurrency things that could go wrong there. I do like the fact that this is now solved, because people were switching to other locking mechanisms, right? The java.util.concurrent locks did not pin virtual threads. And I don't think that should be a reason to switch to other locking mechanisms. I think the reasons that we are used to should still apply even on recent Java versions. So I like the fact that virtual threads have overcome the limitation here.
Concurrency is already hard enough.
Yeah, it's great for all those people still using the vector class. So they've got synchronized methods. Should there be anybody who's doing that? If there are, stop.
Stop. Bad idea. Okay. There are also 3 JEPs related to security libraries. So already thinking about quantum solutions that passwords can get hacked and easier with quantum systems. Is that already one of the goals?
I think it is. So I'm not the greatest expert on these security algorithms. I mean, who is? I read into them and I was like, wow, this is some heavy stuff. But on the other hand, I do like the fact that the Java platform is thinking of, advancements in this case, quantum computing field, to make sure that the platform doesn't become extra susceptible to practical quantum computing attacks, right? And the Java platform has always contained certain security algorithms. Probably we all recognize Diffie-Hellman or RSA, right? And if we keep on using those algorithms in an age where quantum computing advancements are progressing, we really want some more modern algorithms to be supported. So that's the reason that a few quantum-resistant algorithms have now been added.
I've got to say, I just love that. The whole term, quantum-resistant, sounds like something out of, like the Marvel.
But yeah, it's great that people are warning for that the fact that quantum computers will make it a lot easier to break encryption. And it's great to see that although that problem is not that critical yet, we already see in Java improvements coming to stay ahead of this problem.
I do tend to trust the Java platform a bit more here, right? I trusted it already. I mean, not to say anything bad about that, but the fact that that one of my favorite programming language is ahead of the curve here, or at least that's what it looks like to me. I really like that, and it can help us trust the platform for their future as well, right? It's still a very good choice for new software projects because of stuff like this.
Yeah, no, I mean, I agree that the forward-looking nature of this and figuring out what needs to be done before it becomes an issue is a very sensible thing to do. So yeah, keeping Java as secure as possible.
Okay, you had one JEP, Hanno, that you had a separate title for. Tools is JEP 493, linking runtime images without JMods. What's the goal of this JEP?
The JLink tool that is part of the Java platform, you can use that to build a custom JDK that only has the modules that you need, which is the goal to run with JDKs that are a bit smaller, right? And the goal of this JEP is actually to further reduce the size of your custom built JDK. And the way it works is traditionally the JLink tool uses the JMod files that are in the JDK to create a custom runtime image. But every JDK always also contains like a pre-built runtime image, and there's some duplication there, right? So the stuff that is in the JMod files is also in the runtime image that is already present in the JDK. So in Java 24, the JLink tool is extended so that you can use the runtime image that's already there and extract the resources that you need to build your own custom runtime image. And that means that you can further reduce your JDK's total size. And well, in the context of cloud environments, where you copy your container images quite a lot, this can further improve, performance and the time you have to wait for downloading and uploading and that kind of stuff.
Indirectly, it's also related a bit to this speed up of starting up your application. So it makes it all more eco-friendly. You don't need that much storage for your application. You don't need that much warm-up. So again, evolutions within Java in the goal of more efficient systems, correct?
Right. I'm not sure it's that much related to performance benefits, but at least you could say that the platform is getting more efficient here, right? Efficiently using the available bandwidth, for example. And what I like the best about this feature is, again, the context that it is set in, right? So the Java language designers, they recognize that the way that Java is used in the cloud asks for a more efficient use of bandwidth.
Yes, because I mean, this was one of the big goals of JLink when they brought that in JDK 9, was reducing the size of the runtime. And if you look at a sort of a standard-ish kind of JDK, it's about 300 and 350 megabytes in size, which might not sound big by modern standards, because we deal with gigabytes and terabytes and even petabytes. But when you're dealing with containers which have got constrained resources and so on, and it's also the whole idea of security as part of the issue that we're solving. If you use JLink and you strip down to the very, very basic sort of fundamentals, it goes down to about 30 megabytes. So you're talking an order of magnitude in reduction. And that's really just for, having java.base as the module. But once you start adding more things to that, it starts getting bigger again. And the whole idea of this removing the JMod files is to then try and shrink it a little bit further. So it's definitely a good idea.
That's a nice topic that you mentioned. It's also security. So the less content within your runtime, the less errors there can be in there. So that's maybe also a good idea to use JLink and reduce your runtime. You make it more secure because you remove a lot of things you don't use anyhow.
It's called the attack surface. So you're reducing the attack surface of your application.
Then we have a lot of repreviews and finalizations. So this is how these JEPs work. So they have generations or third preview, second preview. We even have
ninth preview.
Ninth
incubator.
Yes. Ninth incubator, yes. Are these now all being prepared to be ready for that long-term support? I cannot call a long-term support version 25 in September. Is that a bit the goal, that this is the final review and then we will see a lot of these in 25?
I think some of them you will. The Vector API, which is the one that's now in its 9th incubator iteration, no, that's not going to be final I can pretty much guarantee it won't be final in JDK 25. The reason I say that is because the designers or architects of the Open JDK have already said with the Vector API, because it's a sort of part of a larger project, Valhalla, they don't want to make it final until they've delivered more of Valhalla into Open JDK. At that point, then it will become final. So there's still a lot of work going on in the background on Valhalla. And until we get that, we won't see Vector API being final. It's interesting to see, though, that even in the 9th iteration, they actually made quite a few changes. So it isn't like it's just being, sort of moved forward as a new incubator without making any changes.
Okay, maybe we can go through the list and see if there's what's most notable about these. So JEP 484 is class file API. So that's a new one, which is finalized. I think it's now included as a standard feature. What's important about this new API?
Depends on your point of view. Because a class file API is more about people who write code that actually deals with stuff in the JDK itself. It's not so much application level API. So that one to me is less interesting, but only from the point of view that I tend to write applications rather than code that interacts with the compiler and things like that.
So maybe it's more important, like frameworks like Spring frameworks who load class files, those will use this new API. Yeah, okay. Good. Next one, 485, stream gatherers is also finalized. What changed there?
Compared to Java 23, absolutely nothing changed. The status has been changed to final. But if you missed it in Java 23, well, stream gatherers are a way to define custom intermediate operations on your Java streams. I think it's a lot like the way that we can already write custom terminal operations with the collector API there. I regularly teach Java courses, and I ask my students to, implement their own filter based on based on the stream gather API. And they're like, what's the point? The filter operation is just already there. And I said, yeah, you have to know the stream gather API. So I like it from a teacher perspective. I like it very much.
Yeah, as you say, it's an extension so that intermediate operations, you can define your own one in the same way we do with collectors. So that gives you that extra flexibility. I must admit that when I kind of looked at the examples that they provide for that, it's certainly something I've not found that haven't been able to use the right intermediate operation in the past. That's not to say that, because maybe my code is not really that complicated. I think giving that flexibility to developers is great, because then if they do want to define their own intermediate operation, they can do that. Probably not many people will in the end, but it's great to have it there.
I had a few students in my class who were used to Kotlin programming, and they really missed the distinct by operation.
Okay, right.
Actually, coincidentally, the one that is also used as an example in the JEP. So then I could convince them that Java does support that if you write your own gatherer there.
Right.
It does support it from 24 on.
I think 22 if you're comfortable leaving the preview flag on, of course.
Which we already mentioned a few times, I think, in the past. You should not do that in production, probably.
Not do that in production.
So now if you switch to 24, you can do it. The next one is the fourth preview of scoped values. Again, did something change there?
A tiny thing changed there because like the JEP says, the entire API is now fluent. So that means that if you want to use a scoped value, you can start using the scope by calling scoped value.where. And in Java 23, there were a few methods. They were called call_where or run_where, which were just shortcuts for scoped value.where, .run, or .call. And the exact same mechanisms are now only reachable using this fluent API. But apart from that, it's the same as before.
And for preview, again, will it become available next time?
I think that one might become final in JDK 25, but that's my prediction. I don't have any inside information.
The next one, 488, primitive types in patterns, instance of, and switch. Again, second preview. What will be changed there?
Again, absolutely nothing. Just a second preview stage to gather more feedback.
Is it then not strange that there is a second preview? Was there not enough feedback to finalize this?
That's a good question. I mean, I don't know enough about how, because individual JEPs obviously have different groups of people involved in them. And maybe they felt that it needed a little bit longer for people to evaluate it before they made it final.
You can give us some insights in how these JEPs work. So there's a group of people who think, this is a good idea. We should add this to Java. So they work with the JEP. Who then decides when something is final enough? Is that the same group, or do they have to talk to the architects of Java to decide what is mature enough to include?
My understanding is that obviously there will be somebody who submits the JEP, maybe more than one person who submits the JEP, and then there will be people who actually work on that. Once the people who submitted the JEP feel that it has got to a point where it's ready for inclusion, then they would then discuss that. There's a whole process that different stages that JEPs go through, and so it would have to be referred back to the architects, so people like Brian Gertz and Mark Reinhold, who would then say, okay, yes, we're happy with that, so we'll make it final.
The vector API, you already mentioned that one. The next one is 492, flexible constructor bodies. So that's placing the super on a different level and do some checks before you construct an object. Were there important changes there?
I don't think there were in this case, no. It exists to gather more feedback. So in this case, they decided that they wanted more feedback from the users in the third preview stage.
We have also 494, module import declarations. What will this bring to the new Java?
Module import declarations were introduced in Java 23. So this is the second preview stage now. And it is like an alternative to many import statements from the same package, right? So you can replace, like if you've got 8 or 9 import statements from the same package, you can replace it by a single module import declaration.
It's along the ideas of introducing wildcards for package imports. It just simplifies things a bit in terms of how you can do that.
Goal again to have some more developer productivity, less code, less things to review, less things to read.
Yeah.
Yeah, which we love, because the less we have to read, the less we can do wrong.
You have to be careful because you don't want to sort of go too far in the opposite direction, which is where you then start introducing ambiguity, and it's hard to see which things are actually being imported. But in this case, it's fine.
JEP 495, simple source files and instance main methods. Can you explain what this is about, Hanno?
This JEP exists to make sure that people that learn Java for the very first time are not overwhelmed, by the mysterious incantations. Public static void main, string array arguments. Get up to speed with a Java file easily just by typing a void main. So the JEP introduces the possibility that a Java file can just contain a void main. What I like about this feature is the fact that it actually works together with the one that we just discussed, module import declarations, because in order to shorten a basic Java file here, that also means that the print line statements don't need imports anymore, because, well, if you have to teach a beginning Java developer what system.out is, well, then you've lost them already, or I can imagine you've lost them there in your train of thought. And that also means that the java.base module is now automatically imported using the feature module import declarations. So you can use a few basic APIs without using imports at all, which is also, again, a more complex construct in the language that you don't have to teach developers who are just starting out. So that also means that the entire collection API, for example, is available to use in these simple source files without having to worry about imports.
I've always struggled a little bit with this particular feature because I get the idea that you want to reduce the sort of hurdle that people have to go through in order to write their very first Java program. So the sort of hello world program, we eliminate a lot of that ceremony. But the problem is that as soon as you start going beyond hello world, you then do need to understand the structure of classes and how that all works. But the one thing I do like about this is that elimination of system.out.println and just println, because that's what we should have had basically from the beginning.
I think that's one of the most clear differences now if you go to teach a very first file. I know, Simon, you're not a big fan of these changes. We discussed this in the previous podcast with the Java releases. But Hanno, you do a lot of trainings. Are you giving trainings to people who are new to Java?
Sometimes I teach groups of students that haven't seen a single line of Java code before. And I don't think they will consider leaving Java behind just because of these 4 mysterious words. But I do find that it helps in them accepting to learn this language because, as soon as I explain that this is the basic construct of starting a Java process, they'll immediately tell me how much easier this is in other languages, right? Mm-hmm. And the group will start talking about, let's learn Kotlin, let's learn Python or something. And I'm there to teach them Java, so I don't want these conversations springing up. So it does provide a more positive attitude in the classroom. And again, as a teacher, I really like that. Though I think I agree with Simon. So imagine you start your Java project with one of these simple source files. Do you still expect it to be present in your project 3 months in, right? I don't really see that happening.
I think this is in combination with JBang, where you then also simply can add a dependency. I think this for education, and I really like it I create these examples by Foojay where you have interaction with electronics. I really like that you can have one single file with some dependencies to explain a very simple principle. But as soon as you create an application, then you have to take that step.
I think I need to make it clear, though, I'm all in favor of making it easier for people to start learning Java. I don't want to try and stop that kind of activity. So it's just, for me personally, I see that, once you move beyond that sort of very, very basic program, you do still have to learn about what does public static void main mean and things like that. So
we have one final JEP in the list of repreviews and finalizations, and that's structured concurrency. What does this JEP try to solve?
This is an interesting one because the 4th preview doesn't contain any any additions whatsoever. But that doesn't mean that no changes are planned, right? Because I know for a fact that a few changes are planned. So to get back to your question, structured concurrency is a way to enable Java developers to express a hierarchy between different concurrent tasks, right? So if you're starting up multiple threads in your code, you could use the structured concurrency API to express a certain relationship between your tasks. So imagine you have a final result, and it can only be constructed if you've got 3 sub results. If you have access to 3 sub results, then you could spawn off a few threads, and within a structured concurrency block, wait for the 3 threads to finish, and then finally you have your final result, and it can be constructed. And one of the benefits of using this API is when one of these subtasks fail, then the other one could get canceled while they're still running, right? Because you already know that you're not going to be able to construct your final result because you're depending on one of these sub-results. Or the other way around, when you're spawning off a few subtasks and you don't care which one of them succeeds, as long as one of them succeeds, then you can also cancel the work that is still running once one of your subtasks has successfully returned. So those are a few of the behaviors that you can create using structured concurrency. Now, to get back to my point about the preview status here, nothing was changed compared to Java 23, but there are a few changes that are written in a JET draft about opening structured task scopes. And so the API is probably going to change in a future Java version. The structured task scope constructors that we now have to use will probably be replaced by a factory method called open, and it will be a bit more extendable, that you can define your own operations. So you can define your own behavior when the scope has to shut down and when it returns the result. I actually spoke to Nikolai Parlok from Oracle about it because I have a talk about this topic and I wanted to know whether it will be in Java 24 or not, and if it would still make sense to talk about the old way that the API worked. And he said we were trying to get it into 24, but we didn't make the deadline right. So then they said let's just leave it like this and work on the new API for the next Java version. So that also means that it will probably be previewed again because there are significant changes, and I don't expect them to make it final. I think they still want some feedback on the changes.
Yeah, I think this is really interesting because we're at JDK 24, and we're still adding new ways of improving how we do cooperating multi-threaded applications. If you think about the history of Java 1.0 had the idea of multi-threading in it right from the very beginning. But of course, writing cooperating multi-threaded applications is notoriously difficult. And the functionality we had at the beginning was so basic. And then we had the introduction in, Java SE 5 of the concurrency utilities, which gave us all the sorts of things like semaphores and mutexes and stuff like that. JDK 7 gave us the fault join framework. JDK 8 gave us streams and parallel streams. And then was it JDK 21, we got virtual threads. So and plus structured concurrency and things like that. So we're continually trying to make life easier for developers when they're trying to do these hard tasks.
This also relieves a bit the danger of using these preview features. As you said, they are not finalized, so they can change. And this is now an example of one that will change because they will make the constructor differently in the next version.
Yeah, so that means that, I hope people listen to our advice and that they haven't used this in production. And the only thing that will break is my demo code, right, for my conference talk. Then it's okay, I'll just change it.
And then we have a few JEPs. You group them together, Hanno, as deprecations and restrictions. That means, is this cleanup that's going on within OpenJDK?
Yeah, right. I actually applied this grouping. Well, I did it also because there were so many JEPs here, but also when I write an article about the new Java release and I send it to my colleagues, they'll be like, yeah, that's very nice, but what things are actually new? I mean, so in the past, I just listed the JEPs based on their order, the numbers that they were giving. They're interesting enough, if it's your kind of thing. But
And they are
Most of my
important because, if you are using them, you also should be aware of them. Like JNI, prepare to restrict the use of JNI. First, what's wrong with JNI and why is it restricted?
I don't think there's necessarily anything wrong with JNI. If you want to use it, there's certainly a manual, right? There's a way to work with it. But I don't think the language designers intend to deprecate the API whatsoever. Simon is laughing, so I'll ask him.
Well, there's a couple of things to say here, because one is that this is kind of related to Project Panama. Project Panama is designed as a replacement for JNI. So we have the foreign memory and foreign function API that's already been delivered into there. So it's trying to get people to move away from JNI. The reason I laugh is because I remember that when we started doing Java right in the very early days, and I started using JNI, and it's notoriously difficult to use JNI because you've got to, create the sort of wrapper classes and wrapper methods, and you've got to find the right libraries, and you've got to create the header files and all sorts of things like that. And I specifically remember talking to one of the people who developed JNI, and I said to him, this is quite complicated to use. And he went, yes, we designed it that way. We wanted to dissuade people from using it. It's like, that's not a great sort of design philosophy, I don't think.
But like this foreign function API makes it a lot easier. So that's a bit the idea. Get people to move to the other side. And I can agree. I didn't do it myself, but someone who cooperates in the Py4j project, he created an interaction with electronic components based on a C class. And it's way more easier than what we used to do with JNI. So it's definitely a step forward.
Yeah, the one thing that I still think is missing that should be in the JDK, and there's been discussions about this, but they haven't put it in yet, which is JExtract. And if they put JExtract into the JDK, that makes the whole Panama stuff so much easier. But there seems to be a reluctance to do that.
Wasn't the problem that JExtract is pretty big and makes the JDK?
Yes. That's one of the concerns, is that it's quite large, and so it adds to the size of the JDK. But with JLink, you could remove it.
We already discussed security and how Java handles security way better than other things, and also is preparing for quantum resistance. But then on the other side, we have permanently disabled the security manager, JEP 486. Is this related, or is it just the security title which is causing some confusion here?
This is one of those things where people look at that and go, permanently disable the security manager? Doesn't that make it less secure? But no, it doesn't. The security manager was introduced very, very early on in Java, because Java had the whole idea of moving code around the network and executing code from potentially an untrusted source. So you wanted to have a security manager that would then limit what untrusted code could do. But the problem is that that's not the way that really anybody nowadays still does security checks for this kind of thing. So there's different ways of approaching that. So they've decided that they wanted to get rid of it because it was quite a big overhead in terms of the burden of maintenance and so on. Having said that, there are still some people who have used it for different aspects, and they haven't provided a direct replacement for that. So some people are kind of just left with like, okay, you've got to figure out how to work around this. So it's a bit of a sort of double-edged sword.
So it's not related to security in the sense of logging in systems and stuff like that. It's really related to how Java code is loaded, and so it doesn't make Java less secure. That's the important message to remember. Okay, JEP 490 is ZGC removed the non-generational mode, so because generational mode was added. Why did it need to be removed then?
The generational mode was introduced because dividing your garbage collector process in separate generations allows you to increase the performance of your garbage collector. In most Java applications, there tend to be many objects that we call young, so that are not around for a long time, and very few objects that are old, that are around for a long time in the heap. So that also means that if you divide your garbage collector into a generational, if you support a generational mode, you will probably collect garbage on the young object much more frequently than on the old objects. The Z garbage collector has supported this since Java 21. That also means that we've got some experience with using it, and as it turned out, it is a far better performance when using the generational mode.
This is one of those things I actually find a little bit surprising because, as you say, there's this thing called the weak generational hypothesis, which is that says that most objects are very, very short-lived and can be collected very quickly. And that's proved to be accurate for the vast majority of applications. So the decision that both Shenandoah and ZGC made to go non-generational in their initial design was quite surprising to me, because I would have thought that you would have the sort of body of evidence is that a generational collector works better than a non-generational collector. But they still went down the idea of, no, we won't use generations. And then they discovered, funnily enough, that the performance wasn't as good as they wanted it to be. So we'll now switch to being a generational collector. So, yeah.
Yeah. I find this garbage collector so fascinating because there are different ones in OpenJDK, and Azul has another one. And how they work, the main goal of a garbage collector is, as a developer, you don't need to worry. It will manage the garbage collector as it should. But on the other hand, if you know how they work and that there are different ones, you can achieve more performance or a better working application. Gerrit Grunwald has an amazing talk about this, the trash talk. And this he really illustrates what young generation is and old generation and how these different systems works.
I think the important thing is, as you said there, and I'll pick up on that, which is, as a developer, you shouldn't think about how the garbage collector is working. So don't try and program to work with the garbage collector, because sometimes people would sort of pool objects and do things like that where it doesn't make sense. So just write your code in the best way for what you're trying to achieve and let the garbage collector do its work. The fact that we have multiple different garbage collectors within the JDK is more a reflection on there isn't one algorithm that works perfectly for all applications. So you can choose different garbage collectors and tune them in a different way for whichever workload you're doing. That said, of course, we have C4 in our platform Prime product, which is pretty much good for most situations, but not 100%.
Let's jump to JEP 498. Warn upon use of memory access methods in sun.misc.Unsafe. If I'm correct, this is one of those classes or packages which was used in the 1 million row challenge. That was a big thing last year. Again, one of those packages, an old package. It even has Sun as the package name. Why should we be warned if we use it?
Like you said, the package is named Sun, so it has been around for quite some time. I think the class was introduced back in 2002, and back then we didn't have the module system yet, so there was no way to restrict access to this part of the JDK. And if you don't restrict access, like it's the same with my kids, right? If I give them a tablet, but I don't restrict the time they spend on it or the apps, they'll probably find a loophole somewhere, and
they find it anyhow.
Right, and they'll spend the entire night playing some kind of game if I didn't restrict it enough during nighttime. And the same thing happened here, right? So people discovered this class and, more recently discovered that you could use it very, very well to score high on the challenge that you refer to. The methods in this class, and more specifically the memory access methods, they became a valuable tool for library developers that were looking for greater power or performance than what standard APIs could provide. Of course, we don't really like the situation, so APIs have emerged in the recent years to provide better alternatives to these problematic methods. And the foreign function in memory API is one of them. And I think var handle is the other one, when you want to manipulate on-heap memory in a safe way. So that means that the methods that are in Unsafe, I think there are over 80 methods in there. They can be replaced gradually. And these two APIs play a huge part in that. I think a few methods are still around that don't have replacement yet. But as of Java 24, in this JEP, warnings will be generated when you use them. And, of course, in a future release, they will be restricted even more. But for now, we get the warnings.
Yes, this is one of the things that turned up in JDK 9, because when we introduced Project Jigsaw, the idea of encapsulating all the internal APIs was what they really wanted to do. But as Hanno says, lots of people, because they were visible, people had actually used them. And so there were things like, Spring Boot framework and Spring had all used the sun.misc.Unsafe, and suddenly it was like, well, yeah, we can't just turn off access to that. It's going to break lots of applications. So they left the capability to access these things, even though they tried to turn off as much of the internal APIs as they could. And gradually we've been trying to work towards this goal of eliminating the need to use these internal APIs by having exposed public APIs. And that's where we get the foreign memory API, foreign function API, var handle, all of those things that then provide a public way of doing these things. And this is just sort of like that one step further towards eliminating access to all of the internal APIs.
And then we have two final JEPs related to 32-bit systems, JEP 501 and 479. So that's deprecating and removing 32-bit support for Linux and Windows. Is this also the evolution of systems? And we see that everything is now a 64-bit system, although I have a lot of Raspberry Pis behind me, which a few of them are still 32-bit. Is this a bit the idea? Hardware is moving on, so we should do the same with OpenJDK?
Yeah, it's more to do with the fact that we don't use 32-bit systems anymore, as you say. I mean, Windows XP is really kind of like the last time that we saw a 32-bit operating system. They deprecated the Windows port back in JDK 21, I think it was, and in JDK 24 they actually have removed the Windows 32-bit port. This particular JEP then says, right, we're going to deprecate the Linux 32-bit port. But if you think about it, the idea of if you had an application that was running on a 32-bit operating system, how likely are you want to move it to run on JDK 24 or 25? It's very unlikely you would, because most of the situation there, you would actually update your operating system at the same time and move to a 64-bit OS, and then be able to use the 64-bit JDK. So it's just tidying up really the OpenJDK source code base.
Yeah, to add to that, Simon, a lot of new features are very hard to implement in a good way, right? In these, so one example is the virtual threads from Project Loom. They don't exist right on the 32-bit ports, because when you create a virtual thread there, they will just create a platform thread instead. So that renders the entire feature useless.
So I think we had all the JEPs. Did I forget something that should be mentioned about one of these?
Well, you said at the start of the episode, we won't go through all of them, but it appears that we have.
Almost, yeah. A bit fast maybe, but people who want to dive in, they can definitely read your blog post, Hanno, on Foojay. There is also already another one I published, I think, a few weeks ago. Yeah. And there will be a lot more content available in the near future about all these new things. It's a stable release. We mentioned it in all the previous podcasts, Simon. Every new Java release is a good one. You can use it in production. It's as good as it can be. It's completely tested. It's as stable as we can say that as a long-term support version. So why should we switch from 23 to 24 or if we are already on 23?
Right, so this is an important thing to get across. The idea of a long-term support release has no bearing on OpenJDK. So no OpenJDK versions are classified as long-term support. That only applies to the binary distributions that you get from those. So Oracle have nominated certain versions as being long-term support releases. Other binary distributions, all of us follow the same pattern as Oracle. So 25 will be the next LTS, 21 was the previous one. But there is absolutely no reason why you wouldn't want to use a 24 in production. The only thing you have to bear in mind is that there will only be updates for 6 months to the source code. And then after that, you would then have to think about, do I switch to JDK 25? So that's the only consideration you really have.
How much Java 23 do you see in production? Is this something which is used by a lot of companies?
I would say the majority of the projects that I visit use the LTS versions exclusively. And in most cases, this has something to do with the way they want to structure their work. I think they don't want a migration every 6 months, and they want, like, for compliance reasons, they want to be able to report that they are on long-term support releases. And in a few cases, they'll have like a dependency on an external product that says, hey, I can only work with Java 21 or 25. But the majority is just, we don't want to migrate every 6 months, or compliancy requires us to be on a long-term support release. But in environments where these topics are not as important, I'll always tell them to just use the latest one.
The one thing I would say is that the only place where I see people who tend to use the intermediate releases, or the feature releases, I should call them, are people who have a CI/CD pipeline that they update on a very frequent basis. So if they're doing very frequent iterations through a CI/CD pipeline, they often will say, well, if we're going to update our source code and our product, we can deliver on a new JDK at the same time, because they've got the testing set up so they can run all the tests at the same time. So that sort of situation might be where you would see people using that. But for most people, they're looking for more stability.
Or where you need a specific new feature that was introduced in one of these intermediate versions. That's also a reason why you can use them. Okay, so 25, we'll have it in September. Is it something we should really look forward? Will it make a big jump from 21 to 25? Productivity, efficiency, energy use, whatever?
I think the one thing I'm going to say about that, addressing none of the points you just raised, is it has real significance, because it's JDK 25 in 2025. We're finally kind of the crossover of the graph.
I don't think there are any JEPs targeted yet, or maybe just a single one. Stable values, I think, is the only one that has been targeted until now. Well, I'm looking forward to stuff from Predicate Valhalla, but of course we can't be sure if it will be part of Java 25. That being said, probably structured concurrency in the new API form will be there, and I look forward to that one.
And it's all the intermediate versions which are between 21 and 25. So all these improvements which were there in 22, 23, 24, they will be there in 25. So you will have a version with a lot of bug fixes, a lot of improvements just within the internal system. So anyhow, it prepares everyone to release, to go for the next long-term support version and be ready for many more years on Java.
Yeah, and one thing I would like to add is we've covered all the JEPs this time, right? But every feature release of Java has like thousands of minor performance improvements and security improvements. I think when my article is published, I'll have a link to the actual release notes, right? And there's always more in a feature version release than just the set of JEPs. So if you're thinking about upgrading, performance should also be a good factor there. I've seen countless of graphs comparing performance of recent Java versions and less recent, and almost all of the time the recent versions outperform the older ones. So that could also be a very good argument to keep up to date.
Yeah, I create the release notes of Azul Zulu every security release and every major release. Like in 23, there were more than 2,000 JDK fixes, which are, part of them is JEPs, but most of them are, bug fixes, improvements, and the whole community contributing to OpenJDK and applying all these things they have found. I always say, if you find a bug in your Java application, you can be sure that it's a bug in your code. But from time to time, people find something which is really an issue in OpenJDK and either file it as a bug or fix it themselves. And that's what I love about this community, that you can, as a volunteer or just a user of Java, you can contribute to OpenJDK and fix something if you found an issue there. Thanks a lot, both of you. Looking forward to having more articles of you, Hanno, also with the next versions of Java. I know it's a lot of work. You spend a lot of work on these, but it's really a very nice overview that you give there. And I hope you like using Java 24.
Yeah, looking forward to it.
Thanks to my guests for joining this podcast, and thank you for listening. Please subscribe to the Foojay Podcast in your app or on YouTube. Keep an eye on Foojay for future articles and podcasts about development and everything related to the Java world.
Give me a Foo, give me a J, give me the friends of OpenJDK.